Lesson 7.4, Graphing Functions.
Graphing the line of an equation can be done in three different ways. The first way we're going to discuss is using a t-table. Now, a t-table is a table of values, x and y, and then we use those values as coordinate points to make our graph. So the first thing we do is we pick a value for x. I usually start with 0 because that eliminates x from the equation. So I have 4 times 0 plus 3y equals 9. 4 times 0 is just 0, so I get 3y equals 9. Dividing by 3, that gives me that y equals 3. So that's my first point. Then I can pick another value for x. I can pick 1, and I get 4 times 1 plus 3y equals 9. 4 plus 3y equals 9. Subtract 4 from both sides. 3y equals 5, and then when I divide by 3, I get y equals 5/3. This is not actually a great point to plot because it's fractional, and whole numbers are easier to plot on a coordinate plane. So now I'm going to do some thinking, and I'm going to try to determine what numbers I can plug in for x that will give me a number when I combine it with this 9 that'll divide by 3. Well, if I multiply by 3, it'll automatically be divisible by 3. So I'll come in and I'll say 4 times 3 plus 3y equals 9. 12 plus 3y equals 9. Subtract 12 from both sides and I get 3y equals negative 3. Dividing by 3 gives me y equals negative 1. So when x is 3, y is negative 1. Now, you technically only need 2 points to graph a line, but I like to find 3 points just to make sure that I didn't make a mistake. If I've made a mistake, the 3 points won't line up in a straight line. So let's look at this, and we can find another value that we could plug in for x that would make this expression divisible by 3. And I know that negative 3 will also work. And I'm going to plug in negative 3, and I get negative 12 plus 3y equals 9. Add 12 to both sides, and I get that 3y is equal to 21. Dividing by 3 gives me y equals 7. So I can plug that back in, and I now have 3 coordinates to use, 0 and 3. 3, negative 1, and negative 3, 7. So when I make my coordinate plane to graph my line on, I need to make sure that on the y values, I go at least as low as negative 1, and at least as high as 7. And on my x values, I go at least as far to the left as negative 3, and at least as far to the right as positive 3. So I'll place a ruler and just double check 1, 2, 3, 4, 5, 6, 7. There's enough room there. I know that's wider than 3 and negative 3. Okay. Put my arrows. And my first point is 0, 3. My next point is 3, negative 1, and then my next point was negative 3, 7. So 1, 2, 3, 4, 5, 6, 7. Now to graph the line, I connect the dots. And this line is the line of the equation 4x plus 3y equals 9. For our next example, we're going to graph 2x minus 7y equals 6. I'll make my x and y t-table. And then I pick some values to plug in for x that will give me y's. Now, I have a 7y here and a 6. If I plug in 0 for x, I'm going to get a number that won't divide by 7. So I want to try to come up with some number that I can use for x that will give me a number divisible by 7. Of course, 7 will go into 7. 7 will go into 14. I can turn a 6 into a 14 by adding 8. So if I turn this into a negative 8 to make a positive 8 when I add it to both sides, that will work. So I'm going to go with a negative 4. So that will be my first x value. That will give me negative 8 minus 7y is equal to 6. I add 8 to both sides, and I get negative 7y is equal to 14. I divide by negative 7, and I get y is negative 2. Now I need to come up with another number that that 7 will divide into. 7 times 3 is 21, so we could try some way to make this a 21. Now to make this a 21, I would have to add 15 to it. 2 doesn't go into 15, so that won't work. I could turn this into a 7, but to do that I would have to add 1 to it, which means my x would be a fraction, 1/2. However, a fraction of 1/2 is not that difficult to graph. Other fractions can be a little bit challenging, but we could do a 1/2. We can turn this 6 into a negative 14 by subtracting 20 from it. And that would make our x 10. So if I did 2 times 10 minus 7y is equal to 6, it gives me 20 minus 7y is equal to 6. Subtract 20 from both sides, and I get negative 7y is equal to negative 14. Divide by negative 7, and I get y is equal to 2. Now, as you can see, between negative 4 and 10 on the x, I've only gone between negative 2 and 2 on the y. That means I'm either going to need to go much further to the positive to get my next value, or much further to the negative. So looking at the 6, what we could add to it to make things that'll divide by 7. 7 goes into 21. We already determined we can't do that because the 2 won't turn into a 15. 7 goes into 28. Now I can add 22 to a 6 to make 28. So that would mean that my x would have to be negative 11. So I'll add 22 to both sides, and I get negative 7y is equal to 28. Dividing by negative 7, I get that y is equal to negative 4. I now have enough points to graph this. However, if we look on my graph paper, I would need to go between negative 11 and positive 10, and I don't have enough space here. So what I'm going to do is I'm going to move to another area on the page, and I'm going to rewrite my table. Okay. So I need at least 21 spaces to make this wide enough. Doesn't have to be very tall, but it does have to be pretty wide. So there's 1, 2, 3, 4, 5. Okay, that's plenty of spaces. Go about halfway, and I'll make my y-axis. My first point is -4, -2. My next point was 10, 2, so -2, and then -11, -4. Now if I've done my calculations correctly, these should line up in a nice straight line, which they do, and I can graph that line. Another method for graphing the equation of a line is to graph using intercepts. Now, to graph using intercepts, this works best when the x and y coefficients divide evenly into the constant that is present. That's when we use this. Okay, so looking at our example problem, I have 3 and 4 both divide evenly into 24, so this would be a good time to use intercepts. Now, intercepts are where the graph hits the x and y axis. The x-intercept is where it hits the x-axis, and the y-intercept is where it hits the y-axis. At the x-intercept, that occurs when y equals 0. And the y-intercept occurs when x equals 0. So to find the intercepts, we can remove the other variable. So to find the x-intercept, I can plug in 3x is equal to -24 and solve for x. So I divide both sides by 3 to get x is equal to -8. This is the x-intercept. To get the y-intercept, I set 4y equal to -24. Divide both sides by 4, and I get that y is equal to -6. Now, in order to graph this in the amount of space I have, I need to make sure I can go -8. So 1, 2, 3, 4, 5, 6, 7, 8. I can make this my y-axis. So there's my y-axis. And I need to be able to go down at least 6, so I'll make my x-axis a little on the higher side. Here's my x-axis. Now you don't have to have exactly even to where your y-axis and your x-axis cut each other off in the middle. You can shift it around to give yourself the space that you need. So x is -8, so I go to -8, 1, 2, 3, 4, 5, 6, 7, 8, and I put a dot right on the x-axis. Y is -6, so I put a dot right on the y-axis. And I connect my intercepts. And this is the equation of the line 3x plus 4y equals -24. Okay, we'll do one more example using intercepts. Okay, let's try 5x minus 3y is equal to 15. I'll set my 5x equal to 15 and solve for x, and then I get x equals 3. I set my -3y equal to 15, and I solve for y, and I get y is equal to -5. I'll make my axes. I put a dot on 3 for the x and -5 for the y, and connect my intercepts with the line of the equation. 5x minus 3y is equal to 15. Okay, so here's an example that we already did using a t-table. And this is where we're going to graph using slope-intercept form. Now, the reason slope-intercept form is nice because if you recall, when we did the t-table, we had to do a lot of calculations to find our 3 points. Sometimes doing a t-table can require many calculations in order to find those even coordinates. By using slope-intercept form, we eliminate the need to do that many calculations. Slope-intercept form is y equals mx plus b, where m is the slope and b is the y-intercept. And this form of the equation tells us our starting point, which is our y-intercept, and then our slope is directions to go from there. So what we want to do is we want to take our equation and transform it into slope-intercept form. So in order to do that, we first move the x to the other side. So we get 3y is equal to negative 4x plus 9. We divide by the coefficient on the y, and we get y is equal to negative 4/3 x plus 3. Now, using our slope to tell us our directions, if our slope is positive, we'll move up and then right. If our slope is negative, we'll move down and then right. The other options, if positive, is to switch both directions and move down and then left, and if negative, to move up and then left. But I find that if you remember that the positive and the negative is the moving up and down, and you always move to the right, it makes it much easier to remember where to go. And this is nice because we don't have to have things that divide evenly, and we don't have to find exact points. So slope-intercept form will work for any equation. You just have to solve for y first. So I make my axes. My y-intercept is 3. So I put a point on 3. Let's label this so we know what we're doing. That's where we start. And then our slope is negative 4/3, which means we're going to go down 4 and then right 3. So I go down 1, 2, 3, 4, and to the right 1, 2, 3, and I put my next dot. So again, we went down 4 and to the right 3. Once I have those 2 dots, I connect them, and I have the graph of my equation. Okay, this was the second example we had done using a table, and again, we had to do a lot of thinking to find whole numbers, and sometimes that's not always the easiest thing to do. So we can convert this into slope-intercept form as well. We subtract 2x from both sides, and so we get negative 7y is equal to negative 2x plus 6. We divide everything by negative 7, and we'll get y is equal to negative 2, positive, negative over negative gives me a positive, 2/7 minus 6/7. Now you might think, well, now I have this fraction that I have to graph. Well, actually I'm going to show you how using slope-intercept form makes graphing the fractions easier. Now our slope is 2/7, so that means we're going to go up 2 and then over 7. Our y-intercept is negative 6/7. So what I'm going to do is, instead of making each of my lines on the coordinate plane equal to 1, I'm going to label them and I'm going to change the scale. So here are my x and y axes, and instead of this being 1, I'm going to make this 1/7. So that will make this negative 1/7. Then, to find my y-intercept of negative 6/7, I say, okay, negative 1/7, negative 2/7, 3/7, 4/7, 5/7, 6/7. Now, our slope is the number of spaces that we need to move. So I don't have to move 2/7 of a space. I move 2 and then 7. And I have my 2 points, and I connect them with a line. So when using slope-intercept form, even if you get a fractional intercept, you just make your scale 1 of whatever the denominator is. So if you had fifths, you'd make this 1/5. If you had thirds, you'd make this 1/3, and then you count the number until you hit your numerator. Now that we've learned how to graph functions using a couple different methods, we want to work on using those graphs for a real purpose. So here's our scenario. We need to rent a car for an upcoming business trip to market a new product in several stores across the country, and we need to rent a car. So we've looked up a couple of car companies. Car company number 1 will rent a car for $199 per week. Car company number 2 will rent a car for $60 down plus $20 per day. So we're going to make a graph of each of these scenarios individually, and then we're going to graph them together to determine the best plan. And this is a scenario where graphing can be very helpful in determining which product or which plan or company to go for. Break-even points in business, a lot of really good applications. So we're going to start with car company number 1. Now we have $199 per week. Okay, now 1 week is 7 days. Slide that up just a little, sorry. Okay, 1 week is 7 days, so at 7 days it's going to be $199, which that's the 200 line, so we're just going to put it right below that line. And then at 14 days, we'll double that. 199 times 2 will give me 398. And here's 14 days, and here's our line for 400, so right below that. And then if we do an extra week, we're going to have another $199, which will give us $597. Here's the line for 600 and the line for 21, so we're going to come just below that. Now, I don't have my ruler, but, and of course that could continue depending on how long we would rent the car for, but here is our graph of the car company number 1 rental prices. Next we're going to do our graph for car company number 2. Now this one I set up a little differently. I do have the same number of days across the bottom, 1 through 21, but I did my prices a little bit differently. I started with $100, and then I went up by 40s so that I could fit a large number in a small amount of space. So what we need to do is, if we rent the car for 1 day, it's $60 down plus $20 per day. So for this particular graph, I'm going to actually make myself a T-chart. Okay, X being the number of days and Y being the total cost. 1 day will cost us 60 plus 20, so $80. 2 days we add another 100 or another 20 to that to give us $100. 3 days we add another 20. 4 days we add another 20. 5 days another 20, etc. So as we go, we're going to go up by $20 each time. So day 1 is just 80. And since I started 100, I'm not even going to really graph day 1. I'm going to go ahead and skip to day 2 and put that at 100. Day 3 will be 120, which will be halfway between here and 140. So I'm going to skip to day 4 and put my dot on 140. Day 5 would be 160, so day 6 will actually be 180, and that gives me enough points. But if we keep going up and skipping every other day, we're adding another $40. So you can see our slope here is up 1 over 2, so our slope would be 1/2, and we can use that to keep building points. Go up 1 over 2, up 1 over 2, and we can graph that line. I'm going to go ahead and extend it out. And then this is our graph of the function for car company number 2's rental prices. Now, having car company number 2 on a graph and car company 1 on a graph is nice because we can see, oh, if I rent it for how many days, it should cost me about this much. But that doesn't really help us compare the companies. So in order to compare the companies, we really want to put these graphs together on the same coordinate plane. So car company number 1 was $199 per week. I'm going to do car company number 1 in black and car company number 2 in purple. And just to make sure, for anybody that has color, I'll highlight this one yellow. Maybe that will help. Does that show up? Yeah, it does. Okay. So car company number 1, I'm doing black, and that one was the $199 per week. So at 7 days, it's just about 200. At 14 days, it was just about 400. And at 21 days, it was just about 600. Okay, so here's my graph for car company number 1. Doesn't quite, oh, that's, yeah, because I can't go down below, I'm not going all the way to 0, as you can see, because I'm starting at 100, so there would be missing space here. So if we kept going down, the 0 would show up down here. Okay, so I've got car company 1. Car company 2, I still have my data points from the other page. So at 2 days, I was at $100. At 3 days, I'm at $120. At 4 days, I'm at $140. 6 days, I'm at $180. 8 days, $220, 10 days, etc. So I'm going to go ahead and graph this line. I'll extend that out. Okay, and I did say that I would highlight car company 1 yellow. Now what this graph tells us, if you look right here, that's day 7, so this is at the 1 week mark. The rental prices are the same. Okay, so in order to interpret this information, if we are renting 1 to 7 days, this line is less. So car company number 1 is actually less. Oh, you guys can't see that, sorry. Okay, but if we're renting for more than 7 days, you can see that car company number 2 becomes less. So we'll do 7 or more days.